Alright, looks like example 4, we're going to go into the book. So if you will just pause this video for a second, go grab your books. You might grab your calculator just in case. We might be using it here in a little while. Make sure you have that on hand. But what we're going to do is look at number 13. If you'll read through it, get some thoughts together, and then hit play, and we'll come right back to this point. Okay, with example number 4, number 13 in the book, it basically has given you this overlap shaded region. So what this means is that you have 3 lines all intersecting each other, and according to, if we made all of these inequalities like this, let's look at this vertical line, x equals 4. Because the shaded region, that's this green area, is to the left of it, what I want to do is figure out what do I need to replace this equal sign with, so that way when I did shade according to this vertical line, should I shade to the right of it or should I shade to the left of it in order to get to the green area? Well, obviously to the left of it. And what you're trying to do is that with all 3 lines and make inequalities out of them. So instead of x equals 4, we obviously want x is less than, or we'll say we want to less than or equal to 4, because it looks like they're all solid lines. Okay, so that's transforming this first one, this vertical line, to an inequality, so that way when we shaded it, it would definitely shade over the green area. We've got to do the same thing for the other 2 lines though, is what should I change that and that equal sign to, and what should I change that equal sign to, so that if I did shade, it would cover the green portion. Okay, well, first thing I want to do really is the vertical line was pretty simple. Obviously the green area is to the left of it, so I need to go less than or equal to 4. But with these other 2, it's a little more tricky. Let's do kind of what we did. Our first steps on the other 2 parts is let's rearrange these so we just get y by itself. And with this first one then, it would be negative y is equal to negative 2x plus 2, or y is equal to 2x minus 2. Okay? Now, if that is this line coming down right here, okay, in order to get to that green area, what I want to do is figure out what should I change that inequality sign to. Should I go less than that? Should I go greater than that? What? Well, because it's obviously this green area is below it, it's in y values that are smaller. So all these y values up this direction are going to be things like 10 to 100 to 1,000. Where everything down below, you see how we're going to get eventually below this x-axis down here? So that's going to treat all those y values that are like the negatives, negative 1, negative 2. So we want to go smaller than that line. So we're going to write that now as y is less than or equal to 2x minus 2. Okay, so we are 2 steps of the way through writing our inequalities. Let's just do the same thing for this third one. Starting out with that one, let me get us some more room. Move this down just a little bit. If I want to get y by itself, I'll have 7y is equal to negative 5x plus 35. And then I go through and divide by 7, so negative 5/7 plus 5. And let's figure out here. Okay, so here's this main line. It's coming through here. That's graphing the 5x plus 7y equals 35. And let's look at the green area in reference to that. Well, look, hey, the green area is actually above it this time. So my inequality for this last one is going to be all those y values that are now greater than or equal to the negative 5/7 x plus 5. And so my answer to this whole thing is this system of inequalities right there. The 3 of these together, that if I went through and I shaded all the values to the left of 4 for the first one, all the values below that line for the second, and all the values above that line for the third, that the area that overlaps all 3 of those shading areas is this green one right here. And that's what you've discovered. Okay, so let's try this one more time. Let's go to number 16 in the book. If you'll pause it, get some thoughts together, maybe try to create some of your own, and then we'll come back and work on this together. Alright, so here at number 16 in the book, I kind of try to redraw the picture as best as I possibly could, but went ahead and labeled all 3 of those lines. And what I did is I just took 2 seconds out and I rewrote the lines so they're in y equals form. So this first one here that kind of cuts through here, instead of being x plus y equals 2, I just wrote it as y equals negative x plus 2. Because now we can go through it and decide, are we shading above or below. And the same thing with this one that was kind of cutting through here. It was 9x plus 5y equals 90. So when I resolved it for y, it became y equals negative 9/5 x and then plus 18. And last but not least, this other one that kind of cuts way down through here, just rewriting that line, got y equals negative 3/5 x plus 12. Okay. So now we have all three of those, and we can start really analyzing the shading. So let's go with this far left one, that y equals, so instead of y equals, we got to change that, but we know it's negative x plus 2. So with respect to this line kind of coming through here, is the green area above it or is it below it? Well, obviously, if I have a y value here, I think this was going by 2, so if that's a y value of 2, obviously shading areas with y values of 4, 6, and 8 are larger. And because all these lines are solid, I'm going to do greater than as well, or greater than or equal to. Okay, so I'll make it equal to parts. There's that first one. Let's go to the next one. How about this one kind of cutting down right through here? Okay, that's that y and negative 9/5 x plus 18. So where's the green with respect to this line? Well, obviously it's to the left, but it's lower than that because if you look at it, all these y values in here are y values of 2, 4, 6, and 8. Where outside on this side, the y values are up at, 12, 14, 16, 18. So we want the y values that are less than or equal to that line. And thirdly, we have that y and negative 3/5 x plus 12. So that's this large one kind of cutting down through here. The shading is a very small part of it, but it's definitely, that right up there is 2, 4, 6, 8, 10. Right up there is 12. We're looking at y values down at 10, 8, 6, 4, and 2. So again, we want to go below that line in order to get the green shaded region. Now, if you really look at this a little more closely, you should see that there's actually a couple other bordered areas in here that we don't really have a line. We can't see the line, but there's something that's confining it. There's nothing here on the left that we can see, and nothing on the bottom we can see, but all this shaded region really is just stuck right here in the first quadrant. And this is a very important keyword we're about to go to, is what do I need to incorporate as far as inequality wise that'll smash the shaded region or confine it into just quadrant number 1. Well, to describe that means it needs to be all x values greater than or equal to 0 and all y values greater than or equal to 0. The combination of these two right there is talking about quadrant 1. So anytime your shading is confined to quadrant 1, you always want to list that out. I want only positive x values and positive y values. And that keeps everything above the x-axis and to the right of the y-axis, hence quadrant 1. Okay, so there's a little trick to that one right there. And we're going to come to back here in just a second. And I also want to make another point here at number 16, and the same thing that we looked at number 13. If your overlap shaded region, if you can take your pen and circle it, okay, then what it's called is a bounded shaded region. If you look back into your book and look at number 12, number 13, number 14, 15, and 16, all of those areas right there, you see how the green is just confined inside of that first quadrant, or it's all bounded by 3 lines? Because you can draw a circle around it. Those are called bounded shaded regions or confined shaded regions. However, if you look at problems like 17 and 18, specifically look at 18, the only reason why that shading stopped was because the picture needed to, it didn't need to cover the whole entire page of the book. But that shaded region is going to keep going on forever and ever and ever. That would be called unbounded. And the same thing there with number 17. You have a shaded region that's bounded between 7 and 3, but it's going to go forever right. And that's because it's going to follow that tube basically forever right, forever and ever and ever. You can't circle it. So that's going to be an unbounded area as well. So just some thoughts to think about. But now let's go on to example number 6. Our goal here in example 6 is to basically graph a system of inequalities. And the system of inequalities is just kind of like what we did with a system of lines. Is we want to figure out kind of where these graphs intersect each other. And we're just going to be doing basically 2 inequalities on one graph. So let's start out with this first one right here. If I asked you guys to graph that, step 1, get y this by itself. So 2y is going to be greater than or equal to negative x plus 3. Or y is greater than or equal to negative 1/2 x plus 3/2. Or x over 2, same thing. Okay, so there's our first line. Let's go and get the information for our second line. So we have 4y is less than or equal to negative 2x minus 2. or y is less than or equal to, divide by 4, so negative 1/2 x minus 1/2. Okay, so now let's go over here to the right and let's see about graphing these two things. Let's see, 1, 2, get us some x values and get us some y values. And with both of these, it looks like we have both solid lines, solid on the left and solid on the right as well, because we have or equal to parts on both of them. All right, so let's graph this first one. We have a y-intercept at 3/2, or 1.5. And from there, I have a negative, so I should be going down from here, which it says going down 1 and right 2. Okay, and we want to connect this with a solid line. So that basically it's a good idea what's going on with that one. Let's come through and do the exact same thing with the purple line, the second line. We have a y-intercept down here at negative 1/2. And again, we want to be going down with this. So we're going to go down 1, right 2. Or let's say up 1, left 2. Okay. You know what? We're not going to be able to see as much of this because we're not going to be able to see as much of this overlap. Let me pause the video for just a second. Let me increase the size of this graph so we can really see, because I want to show you guys where these two lines are intersecting. Because you look at this and you're like, hey, are these lines parallel or what's going on here? Let's just analyze this for 1 second. Let's go back to the two equations themselves. Are these lines really going to ever cross? Do we have an intersection point of each other? We might not. We'll see. You know what? Going back into your repertoire of what you know for parallel lines, what do they have to have? Well, hopefully you're sitting there going, it's got to be same slope. So let's look at these two. You have y is equal to negative 1/2 x. So the slope there is a negative 1/2. You have y is less than or equal to a negative 1/2 x. So again, we have the same slope. So these are parallel lines. That's good, because that's what my graph is showing me. So that's always a good thing to have that compared to. But let's look at the shading. Doesn't mean we have to, has nothing really to do with the shading part, but it was a unique thing when I was looking at this graphing. I was like, I wonder if they should cross. But okay, with that blue line, I want all the y values that are greater than that line. So all the y values greater than, like, let's say a 3/2 are going to be 2, 3, and 4. So we're going to be shading above that line. Okay. Well, let's look at this purple one. It says I want all the y values that are less than that line. So what's smaller than negative 1/2 is negative 1, negative 2, negative 3, negative 4. So we're going to be shading down this direction. Now, in order to answer the full question really truthfully is where do the shadings overlap? Well, do the shadings ever overlap? They can't, because the lines never intersect. So in this case, what we would say is there's no solution region, because the solutions to that system is going to be where the two shadings overlap. And since the shadings aren't overlapping, then we don't really have a solution region. Okay, so let's try this again. Let's go on to example 7 and see what we can get with example 7.